Time to do some more programming streams. It's a nice casual Friday, so got some nice casual code. Probably not going to be trying too hard. Yeah, just feeling like sticking with some easy work, you know. Nothing too crazy. I may as well get right into it. So I actually you can't really see it. It's right behind my face cam here, but I'm just pushing changes up to my GitHub for a second there. Okay. All right, so we're back with things should be working. Yes, okay. We're back with a REPL running here, Clojure script REPL here. We've still got my Clojure REPL here. We've got my Stylo library here, where I'm adding and working on different implementations for various drawing tools with SVG. And here we just have an environment for testing the CAD objects. And I implemented an arc. I had two functions here, sweep flag and large arc flag, that will adjust the certain flags of the arc string to change the hey Canadian gamer girl, how's it going? I just finished implementing these here, which check the angle between the points to put the arc on the right side of the circle, basically. Okay, and to just double check that actually works, I can draw a new circle here. If I zoom in for a minute, let's go, let's see what this looks like. Doing well, just got done with the morning run. Nice. How many kilometers did you manage to run? Oh, what's going on here? Oh, there we go. Right, so that is a big circle there, but that should be okay. Let's see how that works with the arc. Ooh. Something's not quite right, unfortunately. It is this sweep flag here that's incorrect, but let me see. Let's have a look here. We've got this one. Oh boy. Here, this 0 should be a 1. Yes. Switching that successfully draws that. So that means that this is not implemented correctly. I have to consider how to actually do that a little bit, which I need to figure out how to do appropriately. Hmm. Hmm. Okay, so this sweep flag is, I have to fix that. That's the trick here. How am I gonna do this? Shoot, this is always a little bit harder than I initially set out, but that's okay. Hard work's not a problem. It's just difficult, that's all. Okay, so the position of this here, if I want to draw a circle equivalent to it, I'm gonna lazily just kind of guess and check until I have an arc in the right position, and then I'll just kind of go from there. So this middle point here, if I change the y value of it, let's change it to 200. Okay, so it's a little less than that, 195. That's pretty close. Okay, so if I change this here to 195, I should see no change with the arc. Good, but that's not what I'm testing for. I need this arc to actually be drawn along this curve here. So that's what I need to test, or that's what I need to fix, basically. How do I do that? Oh, no, that's not right. This is tricky, actually. A little bit. Let's see, maybe there's some math here that I can have a look at. Let's see. Okay, the second parameter is the sweep flag. It determines if the arc should be moving at positive angles or negative ones. I'm not sure I understand what that means. Let's have a look here. let's see. Let's temporarily do this. Oh, that's the wrong thing. Let's do A1, A2, A, like that. Okay, so what I want to do is get this arc here. A is this list of points. Then I can do apply large arc flag to A. Okay. So the angle values will, they're always going to be positive, aren't they? I think they are. They're a little slow as well. That's probably, or might be, because I where to go? I think I'm casting to a double, which might slow things down. I don't remember. Well, let's not worry about the speed of it for right now. That's not really a big problem for me at the moment. But it does remind me I have to check something quickly here. Okay, we're okay. We are okay. Well, let's do B is equal to 250, 195, 300, 200. Oops. Let's go like this. Yeah. So if we apply this and then we apply to B here, in both cases the angle between them is close to the same. It's not going to be exact because I was eyeballing it anyway, but in both cases it's also true that they're positive angles. Angle A is larger than angle B, so that's not necessarily helpful. It's also, oh, I think I could actually use, if, something with the length of this, the distance to the center point. Let's think about that for a minute. If the length to the center point should be the radius in all cases. So This is really messing with my brain at the moment, unfortunately. Okay, so this is wrong. I want this to be flipped the other way. That's the problem I'm currently facing. The flag check doesn't work. And it's currently let me first of all, let's move this point just a bit closer in. Get a smaller circle on the screen here. There we go. Which puts this to 150, 150. Same problem, of course. Now if I go here to make a slight adjustment to this circle by points here. Oh, I also should put this back to normal. There. Right, circle by points. What I do want also is the center point here. I want to make a, oh yeah, no. I want to make another little circle to mark the center point, like this. And this is just a matter of refreshing until until the change is reflected. Yes, I know. Mistake. There we go. Oh, that was weird. Wait a second. Why is that correct now and that's wrong? So it's unreliable, to say the least. I don't like that. This should make the circle bigger. Yeah. Oh, also, I just realized I can technically yeah, this should, okay, I should be able to do this. G and circle by points P1, P2, P3 should work for me. If I save that, that was a weird glitch, I think, but we'll see. Okay. I thought this would have worked. Circle by points. P1, 2, 3. Yes, please. Oh, it might be, it might exist, but just with the wrong color styling on it. No, that's not the problem. Let me see this now. Arc. I don't understand what's happened here. G tag. G containing a bunch of stuff here. What if I tried that? Concatenate this whole function, circle by points, and then you concatenate the path into that. Maybe that'll work. Not quite. I'm not quite following what is going wrong with my code here, unfortunately. I don't think I should really have to do that technically. I should be able to put it in a G tag like this just fine. Whoops. P1, P2, P3. Okay, that should work. Let's load the file and see if that's part of the issue I have here. Source, stylo, svg.cljc. Typo. Okay. Okay, so that does work. Circle by points should work, right? It does work, kind of, yeah. So why doesn't the rest of this work? I don't understand what I'm doing wrong. Okay. Circle by points. Right? Works just fine, I think. Let's check that to be sure. Yeah, that gives me that whole thing. And then here, if I do a G of this, what happens? That should just wrap it inside another G, which is fine, yeah. And if I do this, if I do this with a call to arc of the same, it should work. Okay, so that does work. Now why doesn't it work if I just do this directly? That's the part that I don't understand. Let's get back to this part here. Okay, this should work the way I expect. Apply arc to A. Right. Apply circle to points to A. Circle by points. Okay, good. Okay, that works. Circle by points. P1, P2, P3, right? Yeah, that looks okay. Looks like it should work. Yeah, it worked now. Not sure what went wrong there. Might have just missed something with my parentheses or something weird like that. I couldn't tell you. I'm not sure. But the point is, this now should, yes, when I refresh it, there we go. Okay, we're on to something now. Okay, so we've got perfect. We've got a situation where I can see the debug thing here. So the reason this works is because my first sweep flag implementation only looked for if y1, oh, I wonder if, no, that's not it. Maybe it is it. Let me change this around. Let's check with and. Maybe it's as simple as this actually. Right, so if I and, if y1 is greater than y2 and y3 is greater than y2, those both, well, I can still make this easier to read like this. Okay, let's see if that changes anything at all. Okay, that didn't solve it, which is fine. We're so close to it, like it's almost right, but just not quite. I'm checking the wrong thing, right? I'm only looking at y values. That doesn't really make sense. Well, let me just ignore my problems for a little bit and try to move on to something else. Oh, also y3 doesn't exist, so that's silly. That doesn't make any sense. What am I even checking here? I'm being silly. If I do x3, y3, maybe now. A little bit of a slow start today, but that's alright. It's Friday, you know. Fridays are kind of lazy days sometimes. Okay. So if I invert these flags, that's me being a little bit lazy, but I also don't think that solves the problem. I'm not really thinking through the solution. I'm just doing guess and check, which is never like a good way to understand things. Right, so that works. But it could easily break, I think, if I do, let's do 200, 200. Actually, let's do 150, 200 in the y. We will do 200, 250, and then we do 250, 200, and that should be, yeah, so this is exactly wrong now. Wait, maybe it's as simple as, it might be as simple as checking to the center line, or to the center point. Let's try that. And then we just do if the y value of P2, so second value of P2, is greater than second of C, then 0, otherwise 1. Well, let's see what happens when I do it that way. Let's also get rid of that. Yes, I know. Okay, so the arc is correct in this case, but let me switch back to, what were the points I was testing before? Let's do these points. Hey, that looks okay. I think we may have solved the problem. I can't be 100% sure, but unless I think through all the possible cases and write them all out, but I don't really want to do that right now, to be totally honest. It looks pretty good though, actually. Of course, the larger we get as a circle, the harder it is to kind of visualize things anyway, which is okay, just not ideal, obviously. 320. Okay. Yeah. Oh, there's a problem. Okay, so we have issues there. Shoot. Okay, well, what's the right thing to do next? Let's go ahead and get rid of this. I do need to, or want to, let me, I'm actually gonna, okay, save this, clear this. I'm gonna shut down this REPL for a moment. And actually, while I'm doing that, just wanna, okay. I will, I'm gonna grab myself a coffee, go to the bathroom for a minute. Be back shortly, it won't be long. All right, there we go. Right, so there was a situation here where there's a glitch right away. Oh, of course, I forgot to turn my REPL back on. Let's wait for that to kickstart. Taking a bit longer. Let's see. Hey Mike, good morning and afternoon to you. Things are going well with me. I hope they're going okay for you. Just checking some. I've got a video working in the background, and I'm just seeing it might be taking up some computational resources, and things are running a bit slow. So, but yeah, things are going well with me. I'm doing okay. Zip that over here. Close that one. All right, there we go. We have a REPL. Let's see that it's working. Yep. Okay, perfect. Right, so I have this situation. Yeah, so I've got the large arc flag working just fine using the I have the angle implementation done, so that is working correctly. It gets angle between P1, the center, and P2, so this angle, this first one, and then it gets the second one and adds them together, and if it's less than 180, then the flag is 0, otherwise it's 1. The only thing I'm fixing now is the sweep flag, which isn't completely working yet. Because I'm not really well, I don't know entirely yet, but I'm not being very rigorous at the moment. I'm just kind of going at it intuitively, which isn't getting me quick result. It's not like the most smooth approach, but okay, let's try that. Looks cleaner than what I wrote. Is angle from points 2D a method you made or in a library you brought in? I made it. I can show you that actually. Let's go. Here it is. So angle from points 2D just takes P1, P2, P3, and the assumption I have is that you're actually measuring like P2 is the point that you're actually getting the angle for, right? You can like you can give any 3 points and there's going to be 3 angles associated with it, right? Because you can draw a triangle between it. So the assumption is the second point you give is like the corner of the angle. So that I should probably write into a doc string or something, but I'll do that later. All it is here is vector 1, vector 2, right, is just the vectors from P2 to P1 and P2 to P3. L1, L2 is the distance from P1 to P2, so the length of those lines. And distance is a function I have as well. Here I assume. Oh no, it's right up here. So as you can see, a little bit of organization of the library is probably due, but that's boring to do on stream. So anyway, distance just basically does, shoot, what's it called? Pythagoras, the Pythagorean theorem to get basically the distance from, anyway, whatever, you can look that up. I don't remember how to explain it very effectively. Anyway, so you use that to get the length L1 and L2. Then N and D are numerator and denominator, and then you just do the absolute value, or sorry, then, which I'll pull up the equation I have this from in just a second. Then all you do is the inverse cosine of the fraction numerator over denominator, and that'll get you the radians, and then you just convert radians to degrees. So that is using this here. This is on, actually, let me, before I forget, put the URL there. Had to calculate vectors by hand. Oh, so here, so this is not a particularly elegant way that I've done it, but so I can explain how I've calculated the vectors very briefly here. If I take, let's imagine a situation where P2 is 3, 3, right? And then P1 is 1, 2. What I'm doing, the only thing I'm doing is, you can construct that vector yourself by doing shoot, you take it's basically x1 minus x2, or boy, I'm explaining this poorly, sorry. P1x and P1x minus 0.2x and P1y minus P2y. Get right? You just subtract the x components and the y components from each other. So in order to do that really effectively, right, you can use this map thing, which in Clojure, what map does is just maps the function here over whatever entries you have. So by that I mean, if I map this vector 2, 2, this list, I should say, 2, 2, and 1, 1, what this will do is, in sequence, it'll say, compute 2 minus 1, and then compute 2 minus 1, and return that in a list. So I'll get 1, 1. Right? So you can just use that to subtract points from each other really quickly. I'm kind of explaining it poorly, and I'm sorry about that. So let me give another. So map is a generic thing. So I can map any function over any list. So I could do, if I wanted to, let's say, multiply an arbitrary list by 2, I could do this function, multiply by 2, and then I give the list here, let's imagine range 0 to 10. That'll give me the range from 0 to 10, which is 0, 1, 2, 3, 4, up to 9. And it'll run it through this function into this argument position, basically. And then map is running that function over all of those things. So I get 0, 2, 4, 6, 8, 10, 12, blah, blah, blah. Sorry if I'm over-explaining and you might know this stuff already. That's my bad if you do. Right? So, sorry. I don't mean to, I'm not trying to talk down, I'm just trying to explain what I'm doing here. So literally all this is doing is saying, hey, P1 and P2 are each going to have an x value and a y value. All you have to do is subtract the x's and then subtract the y's, and then you'll get 2 values in return, and it's a list. That's all I've done there. I hope that makes a little bit of sense. Now they're not the normalized vectors, right? So the magnitude of each vector is still is still greater than 1. Yeah, Clojure has map. It's got reduce as well. If you're familiar with reduce, it's really useful, obviously. There you go. This is a factorial calculation, right? As long as you start your range at 1. If you start your range at 0, the result is always 0. But yeah, so Clojure is I guess you could call it functional. Well, it's definitely a functional language. I'm not sure if map, reduce, and filter, presumably they are fundamental to functional programming. Anyway, yeah, map, filter, reduce. Very, very useful functions in Clojure, and I use map a lot here. Eventually, I want to create, and this I haven't done yet, it'd be way more useful for points and vectors if I could do this. If I could do subtract, right, if I could just subtract 2 points directly without having to do a map in there. But that's not, that doesn't work yet because there's no, I have to define an implementation for minus to handle vectors like this, which can be done, I just haven't done it. There almost certainly are better math libraries out there. I think I just am avoiding dependencies as much as possible. Anyway, this, back to just finishing the thought on this here, I am just using a bit of help from this math exchange answer here. Find angle between 3 points. This is basically the formula. Theta equals arc cos, so inverse cosine of this formula here, which, yeah, you can read it. This is true in 3 dimensions as well, which is really nice. And the way, technically, this could work with 3D points as well, directly, because of how I've done this here, and how the distance function operates, and even how this works. But for right now, I'm just labeling it 2D for simplicity. Basically, yeah, so here lengths are found using Pythagoras, which in this case I called it distance. Might make sense to call it length. Anyway. This is the more general formulation of it. U dot V divided by the magnitude U, magnitude V times each other is equal to cos theta. And then obviously you just invert that. Yeah, so that's what I've done. Then the only things left to do are make sure the flag setting functions are correct. So large arc flag works just fine based on what you had said about finding the angles, and that's exactly what happens here. And then sweep flag is what I'm working on here. What I'm just checking, I don't know if this will actually work. That's the next thing to check. I'm just manually kind of coming up with geometric cases and just visually inspecting if they're drawing the way I need them to. I have to figure out why that keeps failing as well. Use of undeclared variable color element. It's not undeclared though. That's the thing I'm confused about. Let me see here. Right, see color element. Oh, okay. No, wait. Styles up here, right? Color element exists. Composites. Okay, yeah, that does make sense after all. Okay, so this circle by points thing, actually does, okay. This is just me being kind of silly here. Let's put that down in the composites at the end. Save that, that should be good. That'll prevent this from popping up all the time. The reason for that is I was using, so this is declared, but the way my file is organized, it's declared after I was using it, so it assumes it's undeclared because it hasn't read the file yet. Okay, so we've got this weirdness going on, right? So this is the correct arc, but the incorrect side to be drawn on. And so I need to fix that, obviously. Right, okay. So this is one downside to building out a library kind of in this prototype experimental way. Stuff gets shuffled around and doesn't, it can cause annoying errors like that. What I'm gonna do is temporarily, since this is a temporary call into it anyway, I'm gonna go back up to my arc definition here, and what I can do is declare upfront circle by points. So declare basically just says to the compiler, hey, I know you haven't seen the definition for this symbol yet, but trust me, it's there, so it won't throw an error. It might technically slow down compilation, but I'm not in the game of optimizing today, as you might clearly be able to tell. Okay, there we go. So let's see here. Right, so I've got this problem. I'm not sure I'm solving it, I'm just doing that lazy thing. Yeah, okay, so that didn't fix the issue here. So what to do? This is not very readable either, but I'll get there in a second. Basically, oh, excuse me. So what I'm trying to just be lazy and not think about is, I'm pretty sure I have to make a conditional here for 4 different situations, 1 for each quadrant that the arc could potentially be in, but maybe that's not the case. Or sorry, not the arc, but the middle point. I'm not entirely sure if that makes sense. Okay, so we're in a position here where, okay, so things are correct now based on me changing this conditional here. So the flag is basically if the y position of the middle point is greater than the y point of C, or the y or the x point of P2 is greater than the x coordinate of the center point. So if it's here, if it's on this half, or it's on this half, you toggle your flag, otherwise you don't. Okay, so does that really end up with the right result? I feel as if this is not going to be correct all of the time. I have to think about this. Is that going to work? Is that going to work for me? Hey, it does. Awesome. Okay, so what I'm feeling might be necessary is I create 4 kind of test cases here for each quadrant, just to check that the quadrants all work out properly. I have a feeling that quadrant 4 won't. So that'll be a good way to do this visually. I'm trying to think as well if there's a way that I could do this where I could write automated tests to do it, but pardon me. But the issue with that is well, I mean, I suppose I could, but I don't actually know. Doing it visually like this is at least helpful to me, so I am going to continue with the visual inspection approach for the time being. There's a lot of stuff to consider as I write this library out. You know, like the closer I get to a useful library, the more I have to write down assumptions, make more thorough documentation, make more tests, some spec work, and examples. And the examples, I think, will be kind of where I want to put the most direct attention, because that's the stuff that gets people's attention right away. And it's a really good, you know, if you have a good copy-paste story about your examples and people can see it quickly, it's a really nice way to kind of get people excited about it. Right. Let me just, I gotta check. Sorry I'm switching my camera around like that, but okay. Just trying to free up my computer a little bit here. There we go. Right, so back to what I was saying here. I'm gonna make a 4-quadrant test scenario here, and we're gonna do zero, 0. Let's go with a total, let's go with a diameter of 100, so the radius is going to be 50, which means I want the end point to be at 50, 50, and the midpoint to be Oh shoot, what is my brain is blanking here. It's gonna be oops. Mass square root 2, yeah, times 50, right? Am I thinking about this? No. Well, let's be, let's just see what happens if I do arbitrary numbers here. Let's just have a look. What's going to happen anyway? Could not read. Well, you don't say, huh? Okay. Probably an extra one of those. Okay. Right. This is a line, and that's bad. You can't draw a circle from a line, obviously. I'm having a total brain blank on how I would just calculate the exact 45-degree point of this arc. It shouldn't be hard, and I'm just, my brain's just freezing on it. What would it be? Tan theta equals no, yeah. Ugh, my brain. Okay, so if I do 50 times that, is that, let's see if that's correct. Okay, 39.227 should be, wait, oh, come on, brain, you're failing me. Let's move it into position. Okay, so the it's 100, so we're gonna move it 110, 110. 50, 50. Let's start there. Okay. The arc begins at 0, 0, goes 10, 20 to start. It ends at 50, 50. I can actually move it. Let's just get it just away from the wall here. Okay. Yeah, so this point value is wrong because this circle radius is bigger than 50. And that's the part that my brain is not connecting to right now. But I'll get there, don't worry about that. Don't worry about that. Okay, if I create svg/circle of size 50, oh, this color element thing I should make generic, or make it work on lists, because it doesn't yet. I'd offer to help, but my math skills are not up to snuff today. Oh, don't worry about that at all. I am just embarrassingly slow today. You know, Friday's not necessarily a strong math day for me. That's totally fine. It isn't hard, I just am not thinking at all at the moment. Yeah, it's just not coming to me right now. It's a cosine. You could find it pretty easily. Technically. Or I should say one should be able to find it quickly, technically. I'm just not. Everything's all over the place in my brain today. 55. Okay, so that circle, that black circle, is where I want things to line up and where they're not currently lining up, which is totally okay. I just need to get my act together here. Color element, fill, slate gray, perfect. Awesome. Let me see, does opacity work? Oh, it does. Sweet. Okay, there we go. So what I need is SVG translate 55, 55 here. The arc in consideration starts at 0, 0, ends at 50, 50. Okay, so we have the start and end points in the right spots. I just need to fiddle with this thing so that it ends up in the right spot. Theoretically simple, a little difficult for my brain today, but we go with it. Oop, overshot it. Okay, see, that is close to right. That's not exactly. All right, we're gonna be happy with that. And visual inspection means that's close enough. I know the feeling. Woke up and started working and realized I can't type well, much less code today. Glad it's Friday for sure. You know, some days are just like that, and I think it's kind of better to kind of just work with whatever state your brain is in. You know, don't force things too much. I guess, like, you don't want to just use that as an excuse to not put in effort, right? That's not what I'm suggesting. But sometimes you just gotta roll with the state that your mind is in a little bit. At least that's kind of my working hypothesis right now, these days. But we're gonna call that reasonably good for the time being. So next one, let me okay, I'm gonna try something here. Apply partial SVG element on the list of circles, which is going to be like this. Let's see if that works, and we'll translate this over by 100 so we can see. Kinda, but not really. Huh. Okay, that doesn't work. Well, I thought it would, but okay, let me oh, I could also maybe goose it a little bit if I do this, right? And instead of a list, I actually just make it a group, and then zip this for that. Will that work now? Hey, undeclared variable, yes, svg/g. There we go. Okay, perfect. So we're gonna do this over 200 instead. Yeah, all right, there we go. And then this one, copy, paste, paste. Okay, so we've got, there we go. We've got some test cases here. Now it's just a matter of doing the same kind of thing here. SVG/G for this element. Yeah, I heard a guy talking once that even if you get up and code and it's awful, you're still moving forward and you can always modify the code later. But that progress keeps you motivated and it keeps the project moving. I really like that mentality. Yeah, that approach I have learned works so well for me, and really it's one of the powerful things I keep getting reminded of as I do these streams. I mean, I'm not the quickest nor the brightest programmer in the world, but doing this on a stream gives me just enough of a mental thing like, hey, you gotta do it, because I mean, I have committed myself to doing it, and there's a bit of interest and it's fun, and you know, and all that sort of stuff. But it literally forces me for a few hours every day to sit and think about the code I want to produce and to actually write stuff. And it's kind of, pardon me, kind of like a microcosm of that mentality that you just described there, where just do something, and you can fix it. You can mold it later. You can delete it all later for, you know, if you've learned that everything you did was wrong. But the act of doing it really does help. And then you kind of don't need motivation. You just need that initial spark, and then the momentum kind of builds a little bit. I'm pontificating about my stream here, but I'm enjoying that, and I think the mentality has served me anyway quite well. I won't be so bold as to say it is like the right way to think about things, but I know for myself and people who might think similarly to me that it's really quite a nice approach, because it puts the pressure on you to start and to continue things, but it does not put the pressure on you to be perfect. And I think that's really a much better way to kind of force yourself into things. You know, perfection's not the goal. Doing and trying is the goal, loosely spoken, if that makes any sense. Anyway, I'm really that approach and mentality has been serving me well lately. to put it in a more succinct way. Okay. So let me now translate the rest of these around here. If I go plus 200 here, if I go plus 200 here, plus 200, plus 200, does that... What a shame. Why is that? Let's have a look here. It's almost certainly a missing paren. There we go. Okay. Right. Now, for the now for moving the points around here. If I now, let's look at this one here. So we want the starting point instead to be at 50-50. We want the midpoint to be the same in y, so we leave this point alone. And we can just move this one. It won't be plus 50, it'll be plus something that I can't think. Will it be plus 34.75? Does that make any sense? It's going to be 14. It should be 100 minus 14, right? Does that make sense? I think so. 86? We'll see. You can always move it if it's wrong. And then here, our end point should be 0 and 100 in x. Like that. Did it all go horribly wrong? Ooh, it was correct. I love it when that happens. So, like one thing I do a lot, like I'm moving points in like this fake grid in my brain, you know, like I'm drawing it out in my head, which I kind of wonder sometimes if I'm like better than the average person at doing that, because I can do it relatively quickly and I do it a lot. So not because I'm special, just because I, like, through force of daydreaming, I've practiced it a bit. But the obvious problem is if there's a CAD library that literally requires you to just draw it in your head first, the usability is basically zero. So that is why, to some degree, I'm working on kind of more and more understanding a nice way to have this visual representation. And I'm thinking really hard and in the background experimenting a little bit with ways that you can have both. You could write the code directly and click and interact with the visual side, and then the code and the visuals are directly linked, right? Like it would be way cooler if I could go over, I could write the code out, and then, oh, if this point were wrong, I could click and drag it and move it around, and then see live that the values here would change according to where I dragged it. That would be really, really cool. It's not there yet, but it's getting there. And I'm realizing more and more how awesome that would be, because it's a little slow sometimes even for me to try and draw it out in my head, you know? It's like if you're debugging programs, you almost have to like run a compiler in your brain, you know, sometimes, to like parse the code, interpret it, and all that stuff. You're basically running a compiler in your head just to find some error state and then fixing it from there, which seems kind of like, why would we do that? You know, as humans, our brains are way better suited to other things. I mean, we invented computers to do the compiling for us, so why do we do it in our heads? And I'm just having the same thoughts with all of this stuff. But enough jibber jabber. Let's test this quadrant out here. Okay, so we're gonna have 86 here, and then it's gonna be negative, yeah? See, immediately now my brain is not I'm not thinking very hard right now. Yeah, but there we go, that's correct. And last but not least, so this kind of makes sense, I think, right? Based on the sweep flag check that I threw together here, it's just checking if the x and y of P2 is greater than the center point. So it theoretically correctly works on anything on the bottom half of the circle and on the right half of the circle. So we've got, this is on the bottom half, this is on the bottom half, this is on the right half. If this is going to go wrong, if there's an error in my thinking here, it's going to go wrong on this last one, I think. So I'm going to go ahead and test that theory out. So we've got, oh, there's also another thing I will have to try in a little bit, but I'll go there. I'll get there when I get there. Okay, so we've got starting point of this one is going to be 50, negative 50. Midpoint of this one is going to be 14, negative 34. And then the end point here is going to be 0, 0. There we go. My gut was kind of correct that this would be where we see it go wrong. One thing I am curious about is if order of point specification. Yeah, okay. So that is, so that's maybe a bit of a problem. So I can flip all these to be quote unquote wrong by swapping the start and end points, right? That bends the curve the opposite way. I want this to be independent of those situations. So that's not good. So I have to fix that. By that I just mean I want it to be the case that whatever order you give the function its points, or like the start and end points should be able to switch without it drawing incorrectly, right? Like this is correct because it goes through the second point provided. This, oops, is wrong because it completely does not go through the second point provided there, right? That is wrong. I need to avoid that scenario. So this just shows me the weakness of this sweep flag function here, which is good to know. I just need to figure out how to fix it now. So right, this here, -50, and this being 0, 0, and this is the quadrant that breaks down. So what do I do? Let's see here. Right, so like if I it's a bit tricky to clever it. I'm misreading your sentence. It's a bit tricky. My mind goes to a bunch of conditionals as well. Yeah, not ideal in my opinion, but there's gotta be something here. Oh man, it's not. It doesn't jump out at me right now. That's the only thing. And this I did not think very hard to come up with. I just kind of threw it together as a first attempt, and it's obviously incomplete, right? So not good. Well, okay, let's get real messy with it for a minute. If I do an AND here, and by messy I mean there are definitely better ways to do conditionals here. In Clojure there's this cond, which is the syntax is I believe cond is a special form or a macro. But the form is this: you do cond, and then you do pred, or like some condition, and then you do some s expression for value, right? And then for any number of other condition, etc. And then you can finally have an else something else. So that's a cond. It's basically, it's better than some weird if statement, but I'm just gonna be messy for right now because it's better. I don't even have a proper solution, so I'm not too concerned at the moment. Okay, so what I'm doing right here is comparing P2 to the center point only. Is there basically I've got nothing. I'm coming up blank here. Let me just see if some of this SVG documentation is in any way useful. Maybe there's a code pen example that's helpful. I gotta see. Code pen. Oh man, this is a pretty cool utility. Neat. Wow, that's nice. It'd be nice if you could also type the values in, but whatever. I'm not here to complain. Okay, that's not really helpful to me. Oh wow, you can, oh man. Neat. Okay. Yes, yes. Well, I can't totally see. One small issue with how I've set up my stream and everything is it's, you know, I have to move windows in and out a lot because I don't want to necessarily hide what I'm doing from the viewers, but it does mean sometimes that my workspace feels a little restricted, but that's all totally fine. Okay, so this here, when P1 by default, it's always, the arc always kind of is pointing down. Right, so if the things switch over when P2 X ends up less than right, so P2 X is less than P1 X. That is the flipped situation I have here. I guess I could no. I was gonna say maybe I could like manually in the function reorder the points so that it's always drawn a specific way, but that seems counterintuitive. Calculate the slope of a line between P1 and P2, and then based on that return a 1 or a 0. I suppose I could. So slope, like if I take my situation here, P2, right, is the P2 is this middle point here, right? So the slope in this case is negative. The slope in this case is positive. The slope in this case is negative. The slope in this case is negative as well. Wait, did I say that right? This is negative. Technically this is positive slope. Yeah. Or no. So I'm thinking something to do with this switchover scenario here, right? Where if right now I'm dragging P1, and then this is P3, right? So if X of P1 ends up greater than P3, then it points the arc downward, right? And that would be if okay, sweep flag 1. I'm gonna give this just, you know what? Here's what I'm gonna do. I am going to write myself a little note here. The arc should be drawn the same. It also breaks when P1 and P3 here, when P2 is in Q4. Okay, so let me get rid of this and grossness. Let's just make sure the function works. Okay. So I'm gonna go ahead and go back here. I'm gonna refresh this, just make sure. So it should still be broken, but it's at least broken in a way that we're familiar with, which is better than broken in a way that we're not familiar with. I'm gonna go to the washroom for a minute, and then when I'm back I'm gonna start Bezier curves to just switch it up for fun. I won't be long. Okay. Since I'm bored of the arc implementation, I'm going to go ahead and give myself the opportunity now to do Bezier curve stuff. Now, if I were actually implementing like the Bezier algorithm today, that would be a whole crazy thing. there's this whole thing written by this Pomax person that I found really useful for another library I was working on. But Béziers are, for me, they've been very, very confusing. They're really nice though. They're really cool, and it's a fun challenge to try implement. But this is not exactly what I'm doing today. But like, oh, something's a little goofy with the drawing here. Oh, those are maybe not interactive. Let's see here. Right, so this is all explaining the algorithm and the math behind Bézier curves and what they actually are. So they're basically combinations of polynomial functions that, it's a piecewise polynomial function, which means it's a curve that uses all kinds of other polynomials that are like flipped on and off at different parts of the curve, and it gets wild. But it makes for really cool, like a lot of control for curves. But today, since I'm not implementing the algorithm directly, I'm just doing a wrapper over this here, that's, yeah. I'm just doing a wrapper over SVG's path elements. I don't have to actually compute Béziers, I just have to basically provide an interface for the points and stuff like that. So I'm gonna just do the easy thing first and make a Bézier string function and kind of go from there. Right, so let me see how Béziers work in SVG. Okay, there's 3 different commands that can be used to create smooth curves. 2 are Bézier curves, and the 3rd is arc. Arc I didn't handled, so I won't worry about that. There are an infinite number of Bézier curves, but only 2 simple ones are available in path elements: cubic and quadratic. Perfect. So cubic and quadratic are related to the number of piecewise polynomials that are used to derive the final object, the final curve. And they're provided directly by SVG, I'm sure, because they're definitely, well, cubic for sure has a simplified algorithm that you can use to get there, and quadratic is not too complicated, and both are really common relative to higher order ones. But there are limitations as well, like you cannot technically create a perfect circle with Bézier curves without changing a few things, and then they are not Bézier curves anymore, then they're non-uniform rational basis splines, and that's a whole other thing. I'm not going to get into that today. I'm just going to make a nice simple wrapper basically over, well, let's start with cubic Bézier, I guess, because it seems pretty handy. Okay, so it's the more complex curve. Did I mix up cubic and quadratic? I may have inverted the meaning of those. Quadratic might be the easier one than cubic. In fact, yeah, cubic has one more function that you use or something. Whatever. I might have flipped them around. Okay, so we have x1, y1, x2, y2, xy. Okay. Right, let me start with defin cubic Bezier string function. Let me make sure I understand this first for a minute. Oh, geez. Okay, x, y, specify where the line should end. Nice and simple. The other two are control points. x1, y1 is the start of the curve. x2, y2 is the control point for the end of the curve. Really, so you can't control the control point for the start of the curve, eh? Control points essentially describe the slope of the line starting at each point. The Bezier function then creates a smooth curve that transfers from the slope established at the beginning to the slope at the other end. Right, so in this case, in the cubic Bezier case, you only specify 3 points. It's basically, well, I can undo this now too. Oops, we'll just get rid of it this way. Well, let me P1, P2, P3, because why not? Right, so that is going to be, how did I do the arc string here? Apply string to interpose, very simple. Apply string to interpose space between. We'll do cat, oops. Oh, oops, there we go. Interpose spaces between the list of these things, which is just going to be, oh, I should do let here, and x1, y1 is p1, x2, y2, p2. Actually, let me change this up for a minute. I'll do it this way. x1, y1, x2, y2, x, y. And then I don't need the let because they're already destructured right in the argument list here. So apply string interpose this, C, x1, it's very simple, x1, y1, x2, x2, y2, xy, and that's really the whole thing, which means defin cubic Bezier. There really isn't much of a like when it comes to making complex curves and stuff like that, there's no like really concise interface into actually drawing them out, right? Like you need to specify a lot of points. There's no real way around it. Now, I say a lot. I mean, this is 3 points for a simple cubic Bezier. That's not too bad. But things could easily get more complicated than that. Okay. I just call path, and then the string is just cubic Bezier string apply cubic Bezier string. No, I don't need to do that. Right, so here destructuring isn't actually necessary. So let me do it a little differently here. A little more clean, theoretically clean. Okay, let's have a look there. So now if I go over here, just for fun, yeah, that's fine. Okay, here we are. So I can do svg/cubic Bezier. I want to draw from, let's do 10, 10. Oop. 10, 10. Midpoint thing is, let's make it 50, 50. Then the end point is going to be, actually let's make it 60, 50, which means 110, there, 10, yeah. Okay, so this should break for a minute. Yeah, because I need to actually rebuild the site for a minute. Okay, so the site works. Okay, so we have something not working, which is perfect. Okay, let's see here. Is the path actually being drawn, first of all? Let's find that out. Path, oh it is. It just is not a valid path. Okay. Let's see here. Does this work? Do I need to have a move like that first? Oh, I do. Oh, maybe this, maybe it's like this. The first position, yeah, okay, so it starts at wherever the cursor is. So move to 10, 10 is its starting point. Then you start a curve, and its first control point, okay, I see. Its first control point is, right, if I make the control point exactly where it's starting, that's not going to be... Okay, there we go. Kinda. Okay, so it starts at 1010, the control point's 2020. Okay, so I actually have to do this. P1, ooh, what's a good way to... P1, C1, P2, control 2. Let's call it like that. Where, okay, so I actually have to, this needs a bit of work then. Well, let's leave that the same, that's fine. C1, C3, no, C2, and then P2 is the end point, yeah. Ooh, do I want to do it? Let's do it like this instead. C2, P2. Right, so you can kind of visually get the shape there right away. So you know P1 starts, P2 ends. That seems intuitive to me. Seems like a good idea to do it that way. Okay. getting confused here because this is a messy function right here. Right. Let mString apply string to interpose space cons m p1. Then C string is just cubic Bezier string. Yeah. And you call it with C1, C2, P2, right? Is that correct? Where this x1, y1, and x2, y2 are the control points, and then this is the end point. So the start point is defined on its own m thing, and yeah, that does make sense. That should work, right? And then you return, well, I'm gonna make it a G tag actually, and I'm gonna do map circle. Oh wait, we gotta do map translate into the given position, circle of radius 2 to mark the mark the point, and then the points I'm doing that over are going to be all of them: P1, C1, C2, P2, which seems fine. And then I also actually want to do polyline, which takes a list of points. So I just do P1, C1, C2, P2. So those are the visual helpers kind of thing. Then all I'm doing there is now the actual curve shape is just going to be path, where I apply string to interpose new line on the list m string, c string, like this. That's the path. Close the G tag, close the let, close the function. Okay, so that's now a whole thing. If I go back over here and I rewrite this a little bit here, I need to add another point here. Let's do 0, 0. And let's end, so it starts at 0, 0, and let's end at 100, 0. The first control point, let's make it 20, 20, and this last control point, let's make it 20 in the Y and 80 here. So it should be symmetric, I think, if I'm thinking about this properly. And then this will break because I have to reload this. There's a new function definition, so I have to reload it. And there we go. We've got a kind of pretty sort of useful structure there. Will this work with SVG translate? Let's move it to 200, 200. I think it'll work. And just close that. That should, yes, okay. I am quite pleased with that. Okay, that's cool. Is there maybe a way that I could No, that, well, actually, let me do this. If I color element this whole thing and I do fill none, I don't need to change that because it already is none. If I do stroke black, stroke, stroke, come on, stroke width to 1, make it 1. Right, that should apply to the G tag here. But I kind of want to do it this way. G, yes. Does that make sense? Did that make any sense to anyone? I think it made sense to me. Path, oop. Yes. Close the, nope, one thing is wrong here. Got to close color element there. Yes. So this path is in the G tag there. There we go. So I think this will work, unless I'm wrong. Oh no. Oh no. Oh, what did I just do? I minimized Emacs. That was a mistake. There we go. What a roller coaster. Shouldn't that work? Yeah, there we go. Cool. Okay, that looks like actual like Bezier type things, which is pretty neat. So I think it'd be really cool to build a right now for these various things that I'm testing, I'm just putting directly into the function some additional elements to draw. I think it would be really cool to have a to have a macro that I can run over any object that injects what do you call it, like visual debug things like dotted lines and points. Maybe I have to think about how I would actually want to do that, because basically I don't want to have to manually specify all of this additional stuff in every function that I might potentially want to see these lines in, right? So it'd be really cool to have like one kind of complicated macro, just one, that that would kind of inject it in there for me, and I don't have to worry too much about it. Sounds pretty slick. Is it something you think users would use, or is this for debug purposes? Oh, I bet people would use it all the time. Like, I'm kind of thinking that you basically, like, so right here, right? Imagine I'm working on making a thing. Basically, I would use it like this, almost. I'd use it, the macro would be here as, for lack of a better word, it would be visual debug, or it would be show guides or something like that. And then you just run it over everything, right? Then the user can do whatever they want, color everything, and then just get rid of it, save it when they're exporting, or even the machinery that actually builds and compiles the final result just ignores those macros entirely, so that you can see like your final visual output. Now the potential risk there is people might actually want to show that though, like center lines and grid lines sometimes, but not always. So I do have to think about the real use case of that, but I'm reasonably confident that people would like to have those features toggleable. I mean, when I was using SolidWorks, I would have infinite lines everywhere, and I'd keep them on a lot, and then I'd toggle them off sometimes, depending on if I wanted to declutter a certain spot. But this kind of stuff is super useful to have on pretty much no matter what. And in a sort of GUI environment, right, it would be like it'd be really cool to have a button that toggles them on, and then anytime you see these sorts of things, you can actually manipulate them directly. Like right now I can't drag this, but how cool would it be if I could, right? I think that would be sweet. Then you could get cubic Bezier lines just like that. And of course anything you put, you could get. I think that would be super awesome. I wonder what happens if I make these points the same. It should still work. Yep. Sweet. All right. That's pretty cool. I do 40, 60. Yes. All right. 0, 50, 150. Man, this is cool. Sounds like a helpful feature to have, especially if someone like me comes from an engineering background, is using it a lot in other software. Yeah, for sure. So this library, oh, do I have examples of it? I've used this. Let's see here if I have some examples that are worth showing. So in terms of, I can't remember if I've shown this to you already. So this was a tiny prototype of draggable things, right? So the code I have that I can use to drag these points, it needs to be reworked, but I could basically just add it to that, and then suddenly that's all draggable, right? And if you make it toggleable, like you can turn it on and off to control, you suddenly have this very potentially precise ability, right? Now obviously just dragging this out and moving it visually isn't overly precise, but there are ways to, if you make it so I could type in an exact value here, and maybe I could have like a function that sort of magnetizes to grid lines, all kinds of things like that. It'd be really good to have. But there are cases where you don't necessarily need precision for this. Let me see. I'm going to pull up another thing that I've used this library for, but just give me a minute to... I don't want to... I'm going through my file system and I don't want to show off everything willy-nilly. That's all. That's why I'm doing it this way. This is me waiting for my computer to do what I want. It's just a little slow today. Okay, here, yeah. So this here is an example of a quilt pattern. So my mom, she designs and sews quilts. And I use this, like an earlier prototype of this library to create these SVG diagrams. And to make all these diagrams, you kind of, it's a weird thing where you kind of need them to be precise, but not necessarily, right? Like, I don't need to show, like this is supposed to be a 1/4 inch inset, but when I actually wrote it, it's not a real 1/4 inch, and no one's going to be using this to like print to scale and measure 1-to-1. So there are cases where you don't quite need the precision of the library. So it'd be really good to have those sort of visual debug tools available, but you can turn them on and off depending on the domain that you're modeling for, right? Like this is kind of a complicated diagram, but I don't need to show crazy precision of center points and all of that in all of these because they're rectangles and squares, right? So this is just an example of a case where you might not need to show precision or control it as much, if that makes any sense. Anyway, I'm pretty proud of this one, all said and done. But this is using the same library, but it's a very different use case. And I can showcase just one more. Let's see here. Oh yeah, I didn't put a link to it. I have this one. Oops. This is another example. This is a bit different. It's actually running the code in the browser, and this is a isometric view of a little design I made. Parallettes it's a type of gym equipment, but this is an example of if I change this, the actual drawings update with the new value. It's not very clean because this was kind of threw it together rather quick. Anyway, this is also from the same prototype library, right? It's a very different use case, and for doing stuff like this, I could totally see that show grid lines or show guidelines to be really, I would say, necessary for figuring out how to make complicated assemblies, right? This is not complicated, but you know, this dimension is not obvious necessarily from your base height and all that stuff. So two very different use cases, same library. Just makes me think about how exactly I want to implement that kind of a macro or something, you know? Anyway, a lot of fun. I'm quite happy with these little ideas so far. For what it's worth, this is another static version of the page with a few more pictures on it. Both are incomplete, that's why I don't have an actual link to them. Anyway, Bezier. Oh yeah, this, I had opened this up and ignored it for a while. This, I was earlier talking about math libraries and stuff. This Incantor, it's a Clojure computational library. Probably something I should look into more as I get more in the weeds. But one step at a time. When Incantor does plotting and stuff like that. See, this seems like it would be a cool and powerful combination with my library, you know? Anyway, I can close that too. All right, what do we got here? Okay, so I've got a reasonably useful cubic Bezier thing here. I mean, it's about as intuitive as Bezier curves are anyway, right? Like they're complicated things no matter what. Should be definitely be proud of those. Lots of devs don't have personal projects they can point to where they made their own libraries. or used something or even extended a library. Well, so I won't shy away from the fact that I'm very proud of the work I've been doing. One thing I'm very keen to keep doing is like the real reason I'm working so hard on this library is because I love designing things like furniture, computer cases, trusses, complex structures, and all that. And I just think using open platforms and knowing really some of the fundamental math underneath it and how to build a program that can describe those things is like an extremely powerful set of skills. So I love design just as much as I love learning how to write code. So that is a perfect combination for me to keep doing these projects and using the projects and completing projects as sort of a real world test to see how useful the actual code I'm writing is. And since I'm using the code for design work and changing the code based on my design work needs, I have this sort of positive loop where I'm still making stuff, still designing stuff, but I'm proving that the features I put into the library are useful. So I think it's like I almost stumbled into a sort of lucky kind of approach. While I'm bragging for a moment, I've shown this on stream before. I'm not sure if current people watching have seen this. This idea is not totally new to me. I've been working before. I used to do Python stuff. This is an old design. It's torn down. I don't use it anymore. But this here was a little project I wrote in a Python library called CAD query. And I made this sort of post. This is some years old now. The code's not interactive, but this code, when you run it through CAD query, produces this object. And I could even, through CAD query and FreeCAD, I could even export step files, which meant I could write this, export a step file, import it into a CAM software, and actually build out a real thing. Now, this 3D view is one of the features I want to add in sooner or later into this sort of toolbox thing, because I think people love 3D. I mean, I love 3D, and it's really cool to kind of be able to rotate things in your browser like that. This particular design isn't like anything crazy. May as well, here, let me just scroll down to the bottom. See, these are all tubes, right? So it's not overly complicated. But let me get through the rest of these here. So this is the assembly. This was a ridiculous, so overkill frame for my TV. And here, this is a GIF of like, that's an actual laser running the actual program that I part that I made there. Like this is real. And then there it is with the good old Mario Odyssey. It's a totally ridiculous project, but like it's real and it worked. I wrote code that ultimately ended up in this thing here. But some of these features, this 3D view here, I want to integrate in a really reliable and cool way into this as well. So anyway, these are not totally new ideas for me, really, is what I'm getting at. Here's even the first one I did. Simple little project. Also another one that I don't think I'm using anymore. I mean, I don't use it every day. But, you know, these are, I like this because it's code that is used as a tool to create something real in the world, and I think that's really neat. It just captivates my mind. It's one of the reasons I keep working on this. Anyway, a bit of a ramble. Apologies for the sidetrack there. All right. Okay, let's have a look at the other curve implementation here. So I did cubic, and now I want to do no need to apologize. It was cool seeing this stuff. Oh, thanks. I appreciate that. Yeah, it is fun to talk about the real, or some of the real motivations behind this stuff, and it's fun to show it. So thanks for indulging me, I guess. Soon enough, I have a few projects in the wings too that I need to work on more. I do some of it in the background, but I kind of think I need to refocus again, do some of that on stream. I have some more gym equipment I need to make, and soon I think I want to make a better desk setup for streaming and more focused dev work. My desk is a little cluttered. Anyway, those are projects that I really want to get going on. It might be good to put them on stream. I'll have to think about it. Okay, here. The curves move downward, they become further separated. The curve starts in the direction of the first control point and then bends so that it arrives along the direction of the second control point. Okay. Several curves can be strung together to create extended smooth shapes. Often, the control point on one side of a point will be a reflection of the control point used on the other side to keep the slope constant. In this case, there's a shortcut version of the cubic Bezier using the command S. Probably that stands for spline, maybe, or smooth or something like that. It produces the same type of curve, but if it follows another S command or a C command, the first point is assumed to be a reflection of the one used previous. Okay, so if the S command does not follow another S or C command, the current position of the cursor is used as the first control point. In this case, the result is the same as what the Q command would have produced with the same parameters. Oh, did I miss something? They brought up a Q command. I may have missed something here. Oh, cubic one called with C, quadratic one called with Q. No, they're just mentioning Q before they showcase it. That's a little bit weird. Well, let's see here. The other type of curve called with Q is a simpler curve than the cubic one. It requires one control point which determines the slope of the curve at both the start and end point. It takes two parameters. Okay, well, let me go ahead and just quickly fill out the quadratic Bezier thing. It's even simpler, so it just takes x1, y1, xy, like this, which is a Q, and then we do, oops, deleting the wrong things here. There we go. Okay, so that makes sense as a Q string. And then here we go, M string is still P1, C1, P2, right? That makes sense. Yeah. So we just do M string is the same, Q string is quadratic, which takes C1, P2. Very simple. And that should be the same there, right? Let's see here. So we can test that very quickly if we do. Oh, I have to, oop, that's a problem. Quadratic. Always a risk with copy paste work that you forget to change something that does need to change. And then you end up with weird mistakes. Yep. Success. Right, so this will break if I don't comment that out. Save that, refresh this. Let me see if it works. Not quite. Oh, here, this is a problem. This is BQ string. Save that, refresh. Let me just change this. Yeah. I thought I fixed that color element problem. Apparently not. Okay, I have to actually run it in the REPL. I think I messed something up. Ah, yes. Oh, I changed the wrong thing. There we go. Yeah. There we go. Okay, now we have both quadratic and cubic. I wonder, is it the case that if I were to let me see this. If I were to do cubic Bezier, and I have these points directly over top of each other, will the curve change or stay exactly the same? It's different, okay. And actually that makes sense, I didn't know that. It's related to, technically, for different approaches to controlling the spline, the curves, you have knot vectors and stuff where you can control weights. This is kind of like that, but the point I was trying to make is a cubic Bezier where the control points are directly over top of one another is not the same as a quadratic curve with the single control point in the same spot. See that? This is a softer curve. So that's important to know, that you can't just use the one to draw the other. It doesn't work that way. Which is totally fine. Okay, so we've got cubic, quadratic. One thing I haven't done is think about how I need to combine these path functions together, right? Because you can have a path that's made up of a bunch of different lines and even a bunch of different closed paths within. So things can get pretty complicated. but I suppose that's okay. I have to figure it out eventually. T strings multiple Béziers together. Huh. Okay, so you can do so I should probably make a setup here where I'm thinking I should maybe make a quadratic and cubic function where I can take an arbitrary list of points, and then it forms the path string based on like using this T and this S thing here. I think that's a good idea, actually. So right, so what I'm thinking is it works by assuming the first point is the M, then there's the control point, end point. But if you do S, it automatically fills in the next control point on your behalf. And then all you have to do, oh, do I like that or not? Here's what I'm thinking about. If I do something like this, polygon takes a list of points. Actually, let's do polyline. Right, it takes, let's do 0, 0, 90, 50. Let's do 70, 20, 90, 92, 30, 120, 50. These are arbitrary points, really. It's not a big deal. 150, 125, 0. Okay, that should, I think polyline is a valid, oop, there's a cross through there. Shouldn't technically matter, but what I want to kind of do is make a, I want to extend this cubic Bézier function to work on a list of points. Basically, I want to be able to pass it a polyline, and that polyline is like the, what would it be called? The control polygon, right? That defines the shape of this complicated path. So, but then I don't know if I want to use this S functionality, because that can kind of be confusing, because it creates implicit control points if I use S there, which would change the shape of the resulting path, versus letting basically it would be, the pattern would be 2 points don't, 1 point touches the line, 2 points don't, 1 point does, 2 points don't, 1 does, 2 don't, back and forth. Although if you do it with S, then you have a pattern where one touches, one touches, one doesn't, one doesn't, one does, skip, one doesn't, one does, one, I'm gonna try without the S first and see how that goes. Let's just go with that. Let's do define weird cubic. Give things funny names and you can do whatever you want. Okay, so let's actually just kind of do it this way, where what was I thinking? Can you do what happens if you do partition some collection? I need to partition it into chunks of 4 by steps of 3. What happens if I have a list of 5 things? 1, 2, 3, 4, 5. What does this do? 1, 2, 3, 4. Okay, so partitioning. Is there another function? I think it might be partition all. That's not quite right either. Well, let's see here. Okay, so let's assume I need 6, 7, 8. If I do this, I get 2 partitions that exclude the last one. Right, so actually if I just do control with 7 points there, I get 2 partitions correct. So it would be point 1, control point 1, control point 2, point 2, point 2, control point 3, control point 4, point 4. I don't think this is going to result in something that makes sense, but I'm gonna try a very basic thing here for a minute. So if I do points, if I do let cubics, no, let's just call them curves. Let curves be partition 4 with a step of 3 the list of points. So now I've got a list of curves, and I do G apply, no, map cubic Bezier onto the curves. Wrong button. Unable to resolve symbol, cubic Bezier. Right, because I haven't, there we go, that works. So let's try weird cubic. Oh, gotta call it, sorry, my bad. Okay. Well, let's just try it right away in here. If we do polyline, I only need 7 points, so 1, 2, 3, 4, 5, 6. Let's do one more. No. 200, negative 50. Okay, so that's weird, but perfect. Weird's what we need. Okay, what I want to do actually is kind of swap those points around because that's a little confusing here. This one and this one. Oh, this one should be 90, 50. This one should be 120. There we go, kinda. Okay, some weird arbitrary shape. So let's try run the function weird cubic and see what happens when I refresh this page. Okay, it doesn't work, which is fine. Well, let's run it in the REPL then. Wrong number of arguments. 1 pass to cubic Bezier. Ah, yes, okay. I have to do map apply cubic Bezier to this. Let's try it now. Yes, we get something weird, but good. Okay, save it. No, not that. This one. No. Alright, my keyboard shortcuts are starting to get all screwy. That means my time is getting close to done. When it makes foolish mistakes like that, it's a sign that it's probably getting close to time. Okay. Right, so we've got this weird looking thing that is technically 2 Bezier curves together here. And what I have here is the problem of a, oh, what's that called? It's called a cusp, I think is what it is. I think that's the right word. Yeah, so Bezier curve, yeah, that's fine. I guess cusp, it's probably in a B-spline cusps exist. I don't know what this is. I don't need it. I do believe oh, maybe they're just called discontinuity. Yes. This is eventually what I want to get into as well. B-spline surfaces, not just lines. I want to have, well, so eventually I want to do parametric curves. So that's a curve as a higher order function in a single variable t, where you can sample the curve from 0 to 1 for arbitrary precision points, right? You can sample any curve as long as it's a valid equation with a t parameter. Then taking that idea and doing it in 2 dimensions, so you get a u and a v parameter, and you can sample any surface that has a function that is sensible in some way, and then using those things to make 3D shapes. That's some of the eventual ideas. It's cool stuff, but it's for another day. Close that. Okay, point is, this here is a naive sort of implementation, and it has some problems where if I pass in more points, it won't necessarily work, right? Right, like I need to pass in a certain number of points for it to actually make a change, because it's partitioning by 3s. So if I do I think I need to add in 1 more point here. Yeah. Right, but all that's doing is just linking completely unrelated Bezier curves together, so they're always going to have this weird kink in the line that you draw there. So this is the thing that the S thing is actually meant to eliminate, so you get smooth curves through there. I probably want this as an option, but I also am gonna want this S thing as an option as well, because it does make sense, right? Basically, you can, instead of having to specify 3 points to add to the line, you just have to specify another point and its control point, and that'll shape things in a nice continuous manner. So this weird cubic function is a good approach, or a good first pass, but it's not what I need. I also think I'm going to change how I do this briefly. I'm going to put cubic Bezier string. Instead of splitting, I do this here. I do the M P1 in the cubic Bezier function, but I think I might do it in here. This I can make way shorter. String M P1, which I'm gonna do like this. Wait a minute. There we go. CX2, CY2, XY. It's kind of confusing. X1. Y1. Not the most elegant, but it will work. That's M string, done. And then this is A string, or C string I should say, which will take just have to change this to that, and that's good. But I do need to use the proper let approach here. Apply string to that whole madness. Then the string you return is actually just going to be string together m string c string like this. Let me see that that works. Okay, so let's just take 1, 2, 3, 4 points. Doesn't matter really which points they are. Cubic Bezier string of these values gives me a hypothetically valid point string here. Let me cap it off with a new line character at the end here for good measure. Okay, so that's the cubic Bezier string function. Now, then cubic Bezier actually is way easier. I don't even need the let here. I just need this polyline. Yes, that's still good. And then path, I can actually just pass in a call to the function directly without having to do any weird additional work to it. Cubic Bezier string P1, C1, C2, P2. Okay, that should work without any issues. Quadratic needs the same change. You know what? Let me delete it and work on just cubics for the time being, because I am not convinced that my approach is guaranteed to be the most effective yet, so don't want to go overboard with things. Okay. Whoa. What's this now? What is this? Zoom, please work. Okay, this color element thing, I was quite sure I fixed it, but I did not. Let me go way up here and just do this then. Declare color element. Okay, I'm gonna have to get going soon, but I want to start writing this weird cubic thing. I want to actually incorporate properly the concept of this S addition here. And then actually I do wonder if instead of this I should just have a space character, because then I can string a bunch of those. No, let's leave it like that. And then I'll make the defin S string. Ooh, that's not S Bezier string. There, that's a little clearer, kinda. Right, which takes a control and a point only. So it takes a control point x1, y1, and a cx1, cy1, and then a x and a y like that. Yeah. Okay. All this is the apply string to interpose space in the list S cx1 cy1 x y. I think that's correct. Let's test it. S Bezier string 0, 0 is the first control point, and the y point is 10, 20, or the first point S001020. That seems to be what I need. Only thing, actually, let me get rid of that new line entirely, because I'm going to build up Béziers by doing the first 4 points. You have to call cubic Bézier on it. Any subsequent points, you just basically you append the S string to it. So if I do what do I call this? Well, weird cubic 2. How about that? Weird cubic 2. Electric Boogaloo. Classic, hilarious joke. So let curve 1 be apply cubic Bézier to take 4 from points. That gives us the first curve. String. Oh, shoot. It has to be apply cubic Bézier string, like this, actually. And then S curves is a mapping of the function apply S Bézier string, and you map it over okay, if I have some list of points, if I take 4 from a list of things, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. Right, take 4 does correctly pull 4 from there. If I do drop 4, I should see 5, 6, 7, 8, 9, 10 is what I want. Yes, okay. So here I have to apply this mapping to partition by 2 of the list drop 4 from points, so that you don't put the first 4 into the rest of your curve. And then all I do is if I cons A onto B, C, D like this, does it put it at the front? Yes, it does. Right, so here I can do apply string to interpose space of cons curve 1 onto the list S curves. That should be the right string. Oh, I have to do path this string. Okay, let's see if it works. Okay, it seems to. Let's just go ahead and do weird cubic 2 right away. Save this. If this works even half well, then I'm gonna be a happy man for the weekend. I'm pretty sure it can work. I just need to make sure. Something's going wrong here. And it is go ahead and just, oh wait, I kind of need to keep that group there, actually. Okay, that looks like it should be right. Well, let's call it in the REPL then. Should work. Maybe I didn't save. Oh, come on. Keep pressing the wrong button. Okay. Saved it. What? Translate. None of this is making sense to me. I'm gonna off stream. I'm gonna have to go dig into these errors and stuff. It's not. This is not very good right now. Okay, so we have something weird. Okay, here's a path. This path is just a normal list of lines and stuff. Now, why is that? Wait a second. That oh, it's related to this. I shouldn't translate it. I think. Ah, yes, okay. So that's something I will work on, but oh wait, shouldn't, if I do this, if I wrap it in a G, it should be okay, right? Yeah, okay, cool. We've got this thing now. And what happened to oh right, it's because I should do something like this basically. This G tag here, like this. Last thing to do, and then I'm gonna be calling it for the day. This is just translate circle 2. I want to map that over the list of points to see all the points, and then I want to make a polyline from the list of points as well to see the curve, or the control polygon. Okay, save, refresh. There we go. Cool. Okay, so this is really good progress. This is one of the things that's weird about Bezier curves, right? Is the polygon you pass into the function doesn't necessarily intuitively map onto the shape that is built from the whole thing. This is not immediately obvious to me, right, why it is this way. Now, since I understand that, okay, if I follow these first 4 points I know are just a normal Bezier curve, and then I happen to know that there's an implicit point right here mirrored from this one, like that, And then the next point is, this is a control point, and then this is the next point that's guaranteed to touch. Then I know that there's another control point here, and then this is another control point. Technically the polyline I'm drawing is not correct. It's missing mirrored like mirrored points here, so it's not necessarily the smoothest, but it creates a smooth curve, which is really quite nice. So I'm gonna be happy with that for today. I've got to go get some food, do a workout, and then go hang out with some friends, because it's the weekend and I'm looking forward to relaxing a little bit. That's gonna be me. Hope everyone else manages to have a good weekend, manages to do the things they want to do. Yeah, Mike, you take it easy too, okay? And looking forward to the next stream. Yeah, I am too. I'm really enjoying that you're coming in and chatting a little bit and enjoying the stream. So thanks for that. I really appreciate it. Yeah, enough jibber jabber. I'm heading out for the weekend. Have a good one, and I'll see you around.